Today we are going to talk about quadratic relationships. How are we going to define a quadratic relation? Is an equation which is in the form of y is equal to ax squared plus bx plus c, where a cannot be equal to 0 because if a is 0, then 0 times x squared is going to become 0, so y becomes bx plus c, which is just a linear relation. Examples of quadratic equations are, for instance, negative 5x squared plus 4x plus 2, where a is negative 5, b is 4, and c is 2, or a relation like negative 4x squared. In this case, a is negative 4, b is 0, and c is 0. Remember that a is the coefficient of x squared, and it can't be 0. Now, we define the graph of a quadratic relation, a parabola, which has a U-shaped curve. In this case, the parabola opens downward. We can have a situation that the parabola opens upward, which is something like this one. Both of these cases you will see in future lessons. The way that the parabola opens depends on the sign of the value of a, which is the coefficient of x squared. Another point that we have to remember is vertex. The vertex in a parabola is either the lowest point, the highest point. For instance, in a parabola which opens upward, something like this one, the vertex is this point, which is where the direction of the function changes. Here, f of x or y is decreasing. It gets to this point and then it starts increasing. So this point is the vertex. In this parabola represents the minimum point. In a case like this one, the parabola is increasing here and then it's decreasing here. This point here, which is the maximum value, is called the vertex. As I mentioned before, the graph of a quadratic relation, when it's plotted, is called a parabola. Now, for any quadratic relation, remember the quadratic relation is in the form of y is equal to ax squared plus bx plus c, where a cannot be equal to 0. The second differences are constants. Just to recall what you learned in grade 9 and 10, the first differences are the difference between the y values, and the second differences is the differences between the first differences, which I'm going to show you later on. But remember, if you find that the second differences are the same, this represents a quadratic relation. Another property of a quadratic relation is that every relation has an x squared term. And the reason is that, remember that y is equal ax squared plus bx plus c, and a cannot be equal to 0. So x squared is always there. And we call a quadratic relation has a degree of 2. This means a linear relation which has the form y is equal to ax plus b has a degree of 1 because the exponent of x here, you don't see it, is 1 here. For a quadratic relation, ax squared plus bx plus c, the degree is 2 because the highest exponent here is 2 here. The exponent of x here is 1. That's why the degree is 2. In the first example, we have a table of value which is shown here. We are supposed to find the first and second differences. Remember, the first difference is the difference between the y value, the consecutive y value. How do you find it? It's very easy. You say 6 minus 1 is 5. 9 minus 6 is 3. 10 minus 9 is 1. 9 minus 10 is negative 1. 6 minus 9 is negative 3. And 1 minus 6 is negative 5. This is the first differences. Now, since the first differences are not the same, this means that this relation, which is represented by this table of value, is not linear. Now we continue to second differences. 3 minus 5 is negative 2. 1 minus 3 is negative 2. Minus 1 minus 1 is negative 2. Minus 3 minus minus 1 is minus 3 plus 1 is negative 2. And minus 5 minus minus 3 is the same as minus 5 plus 3, which is negative 2. You can see that the second differences here, they are all equal, and they are equal to negative 2. So this means that this table of value represents a quadratic relationships. The next part says, is the relation linear or quadratic? Explain. We have to say that it is a quadratic because the second differences are the same, equal to negative 2. The next example, we are supposed to plot the graph of y equal 3x plus 4. First of all, by looking at the graph, you can see that the degree, which is the highest exponent of x, is equal to 1, because x just appears here, and the exponent, although you don't see it, is equal to 1. So the degree is 1. Since the degree is 1, this is a linear equation. To plot this one, we just need 2 points. So I'm going to plot the table of values. Let's say when x is equal to 0, I get y is equal to 3, open bracket 0 plus 4, which is going to give me 3 times 0 is 0 plus 4 is 4. So when x is equal to 0, y is 4. Let's pick another point for x. Let's say x is 1. Then y is 3 times 1 plus 4, which is 3 plus 4, which is equal to 7. Now we plot the points. When x is 0, y is 1, which is here. When x is 1, y is 7, which is going to be this point. Simply we connect the points together and we get a line shown here. The next example is to plot y equal to 2x squared minus 5x plus 3. In general, when you are planning to plot any relation, first find the y-intercepts, the x-intercepts. If you are dealing with a quadratic, find the coordinate of the vertex and also find another point, extra point. So let's see how we can go ahead and plot this one. Let's first find y-intercept. Y-intercept by definition is when x is equal to 0. So when x is equal to 0 here, I'm going to get y is equal to 2 times 0 squared minus 5 times 0 plus 3. 0 squared is 0, 2 times 0 is 0, so this one is 0. 5 times 0 gives me 0, so minus 0 plus 3. This gives me 3. So if I have a table of values here, I can say when x is equal to 0, y is equal to 3. This is the y-intercept. Now let's try to find the x-intercept. To find the x-intercept, by definition, is when y is equal to 0. So I have to solve the equation 2x squared minus 5x plus 3 is equal to 0. This is a quadratic equation equal to 0, and we have to use quadratic formula. If you recall from grade 10, the quadratic formula says that the roots or the values are x equal to minus b plus or minus square root of b squared minus 4ac over 2a. In our case, minus b is going to be minus 5, which is 5, plus or minus b squared, which is negative 5 squared, which is 25, minus 4ac, so it's going to be 4 times 2 times 3, divided by 2a. 2a is 2 times 2. This is going to give me 5 plus or minus. 4 times 2 is 8, times 3 is 24. 25 minus 24 is 1. So this one is going to give me 1. Square root of 1 is just 1. So this gives me 5 plus or minus 1 divided by 2 times 2 is 4. Now this gives me two solutions depending on plus or minus. If I go with plus or if I go with minus. If I go with plus, I get 6. 5 plus 1 is 6 over 4, which is 1.5 if you use a calculator. If I go by negative, 5 minus 1 is 4 divided by 4 is 1. And since these 2 points are the x-intercepts, the y value is 0. So the table of value becomes when x is 1.5, y is 0. When x is 1, y is also 0. Now one thing we have to remember is that the coordinate of the vertex, the x value of the coordinate of the vertex, is the average of the x coordinates of x-intercepts. Meaning, if you find the average of these 2 points, that's going to be the x-coordinate of the vertex. How do you find the average? Very simple. We just add them divided by 2. So, to find the x-coordinate of the vertex, I'm going to add 1.5 plus 1 divided by 2, which is 2.5, divided by 2, which is going to be 1.25. This is the x-coordinate of the vertex, meaning if I plot a parabola like this one, the x-coordinate of this point is this average, which is 1.25. Now, how do we find the y-coordinate of this point? It's very simple. We just put it back in this equation again. So I'm going to say y-coordinate is equal to 2 times 1.25 squared minus 5 times 1.25 plus 3, which is equal to, if you use your calculator, negative 0.125. So we have one additional point we can add to table of values, and that's the vertex, which is 1.25 and negative 0.125. Now we can add another point, any point that we decide to try. One point that we can use is when x is equal to 2, for instance. This is just by guessing. I'm just picking x equal to 2. If I pick the point 2, then I'm going to find the y value by subbing back in this equation. So I'm going to say y is equal to 2 times 2 squared minus 5 times 2 plus 3, which is equal to 2 times 2 squared is going to give me 2 times 4, which is 8, minus 5 times 2 is 10, plus 3. Now 8 plus 3 is 11, minus 10 is 1. So the last point that I'm going to pick is point 2 and 1. Now we can go ahead and plot the points in our table of values. When x is equal to 0, y is equal to 3. So this is going to be the point. The next point is when x is 1.5, y is 0. X equal to 1.5 is going to be a point here, which is shown. When x is 1, y is 0. So it's going to be this point. When x is 1.25, y is negative 0.125. So it's going to be somewhere in between these 2 points. Somewhere around there. When x is 2, y is 1. When x is 2, y is 1, which is this point. So our parabola is going to look something like this graph. Now, you can see that the parabola opens upward, and the reason that it opens upward is because of the a value. If you look at the a value, a is 2, which is positive. When a value is positive, parabola opens upward. The last part of the question says which of the relations that we plotted is quadratic. You can see the second one was a quadratic because it had degree 2, and also the graph showed that it's a parabola.